Okay, so in this video you are going to learn how to find the area of a sector. So I want you to brainstorm really quick, what do you think a sector means? Okay, hopefully you thought of the word section. That's what I did. So when you think of a sector, think of a section, which is just a piece of something. It's a part of something, but it's not the whole thing, okay? So we're going to be finding the area of a piece of a circle, basically, okay? So area of sector is similar to arc length, but I'm going to be finding area. So instead of dealing with circumference, I'm going to be dealing, like I said, with area. So your measurement, or your formula, so you're going to have the measure of the angle over 360. And you're going to times that by pi r squared. And that comes from the area of a circle. So hopefully you know how to find the area of a circle from your previous classes. And then we're just going to find the central angle divided by 360 and multiply through. So very similar to arc length. So if we wanted to do this example, this central angle is going to be 72 degrees. So if I wanted to find the area of the yellow region, I would say 72 over 360 times pi, and then my radius is 15, so 15 squared. Okay, so I would type that in the calculator, and if you would type this multiplied by 15 squared, because we want to leave pi out, you would get 45, and then we would drop pi down. So the area of that section would be 45 pi. Okay, so that's the most simplified and exact answer for finding area. Okay, so let's look at some problems. So you have a circle with a radius of 4 inches. So I'm going to draw a circle, and my radius was 4. And then what is the area of a sector bounded by a 45 minor arc? So let me draw a minor arc and say that that would be 45 degrees. Leave your answer in terms of pi. Okay, so I'm going to plug it in the formula. Now I would say 45 over 360 times pi r squared, and my r is a 4. Okay, so when you type 45 over 360 and times it by 16, because 4 squared is 16, you would get 2, and then we'll drop down our pi. So 2 pi is the area of this part of our circle. Okay, so pretty straightforward. It does get a little bit harder, but why don't you guys try the next 4 on your own? Press pause and we will go over them. Make sure you are leaving your answer in terms of pi. This one on the top left, it was pretty straightforward. All you did was 45 over 360 times pi r squared, plugged it in, and you got 40.5 pi, or you could have said 81 over 2 pi. I'm going to go bottom left first, and then I'll go top right. This one you had to do a little bit more math. So you wanted this piece over here. So you had to know this was a semicircle and do 180 minus 120 to get 60. You also had to know that the diameter was 20 or 26, so cut it in half to get 13 for your radius. So a little bit more knowledge of circles in that one. You would get 169 over 6 pi would be the most exact answer, or decimal wise you would get 28.16 repeating pi. Alright, this top right, you could have done it several ways. I think the quickest way is to figure out what all of that yellow is by doing 360 subtract 45, and you would get the whole major arc was 315. So I did 315 over 360 times pi r squared. Again, if your diameter is a 16, that means your radius is going to be 8. So that was the quickest way. You could have also broke this down into finding the area of this piece and adding it to the area of this piece. So I did that down here. So I did the area of the semicircle, so 180 over 360 times pi 8 squared. And I also found that this little piece right here was 135 degrees. So I did 135 over 360 pi times 8 squared again, When you type them in without pi, you would get 32 pi and 24 pi, which if you add them together, you will get 56. So if you wanted to go about the longer way, you can, or you could have gone the quick way. But that's how you find area of a sector. So let me know if you have any questions on that. Otherwise, it's time to get hungry. So you can think of a sector like a pizza. So you want to get the most sauce. The sauce and the cheese and pepperonis would be, you know, the area of your piece of pizza. And then if you want to think about arc length, that'd be the crust of your pizza. So you could actually measure arc length of your pizza. So here's how circles are used in agriculture in the real world. So in Saudi Arabia, they've got sector farming. So they have farms in circular. So the circular shape of the field is created by irrigation booms with a diameter of up to 500 meters, and these booms apply irrigation water and circulate nonstop, resulting in circular fields from 50 to 100 that are constantly damp. So they do use circles in Saudi Arabia. Okay. All right, but time to get a little bit harder. So let's look at this first one. You got a pizza divided into 8 equal pieces. The diameter of the pizza is 16 inches. What is the area of one piece of pizza? So first off, we need a degree and we need a radius. Okay, so if the diameter is 16, I know I can cut that off in half to get a radius of an 8. Now if I have 8 equal pieces, to figure out what each little measure of the pizza is, I would say I've got 360 degrees divided by 8 people. So if I do 360 divided by 8, you should get 45 degrees. So basically each slice of pizza has got a 45-degree angle at the center. So the area of one piece, I would go ahead and plug it in. So 45 over 360 times pi r squared. So let's do that really quick. And you get 8 pi. Okay? So if I wanted to see what that was about, I would type 8 pi in the calculator, and I would get, it's about 24.13 square inches or square pizza. Cool. All right, moving on to some harder topics. Let's brainstorm on how we can find the area of the shaded region. So I have a square. I'm assuming that's a square. On top of a circle, and I want to find the outside of the area. So first off, what you have to do is find the area of the square. And then I'm going to take away that circle. I'm going to cut it away. So I'm going to subtract the area of the circle, and that's going to give me what's remaining. Okay? So the area of a square, remember, is length times width. So I would have 2 times 2. So the area of the square is 4 feet squared. Now for the area of a circle, the formula is pi r squared. So I need to find the radius of this circle because I know the whole thing across is 2. So that means the radius would be a 1. So the area of the circle would be pi 1 squared, which is just pi times 1. Which is just pi. So I would do 4 minus pi, and that would give me the area of that outside shape. So 4 subtract pi would be 0.858 feet squared. So again, we're squared because we're talking about area. Okay? So that's how you find the area of a shaded figure. So let's talk about how this applies to sectors. So what we're going to be given is we're going to be giving a sector. So I'm going to be given something like this. And I'm also going to be given a triangle, probably, is the most likely of shape. And then I'm going to want to find, what if I took out this piece? Can I find that little piece up there? Okay. So what you're going to have to do is you're going to have to find the area of the sector. And you're going to have to subtract the area of the triangle, and that's going to give you what's left, okay? So remember, area of a triangle, your formula is 1/2 base times height. And that's going to be the probably trickiest part, is finding the area of a triangle. Okay, so let's look at this first example. So I've given a sector. I have a right triangle in there, and I want to find the measurement of this tiny piece. So first off, find the area of the sector. I know this box means 90, so I can go ahead and do 90 over 360 times pi, and then your radius of a 4 squared. So first part's not that bad. 90 over 360 is 0.25, and times that by 16 pi. So I would get 4 pi. I'm going to leave pi out of the answer. So 4 pi is the area of the whole thing. Now I need to find the area of the triangle. So what I'm going to do, I'm actually going to redraw this triangle right side up. And that's a right angle, and this is 4. Okay? So notice, this is a radius, okay, from Q to P, and so is Q to R. So if the radius from Q to P is 4, so is this radius down here. Okay? So the legs of the triangle were 4 and 4. In a right triangle, finding the area is the easiest because you have the height and you have the base. Okay, so you're just going to plug it in. Area is 1/2 the base times the height. So half of 4 times 4. 4 times 4 is 16. Half of 16 is 8. Okay, so that area of the triangle is going to be 8. So now, I just need to take the area of the sector and subtract the area of the triangle. So I'd say 4 pi, subtract 8. Okay, and that'll give me my final answer. So let's type 4 pi. So I would get 4.57. Okay, so that is going to be the area of this tiny shape up here. Okay, not that bad. It does get a little bit harder if it is not a right triangle. Okay, so we're going to talk about that example next. Alright, so what I noticed about this triangle is it's not a 90-degree angle, okay, but it is a nice 60-degree angle triangle. So again, if this radius is 18, so is that. But first off, I'm going to find the area of the sector. So I'm going to find the area of this whole thing right there. So 60 over 360 times pi, and your radius 18 squared. So do 60 over 360 times 18 squared. It's going to give you 54 pi. Okay, now comes the hard part, finding the area of the triangle. So what I'm going to do, I'm going to draw this triangle again so we can kind of get a better picture. This was 60 degrees, and then my two radiuses were 18. Okay, you have the base of the triangle, right? But we do not have the height. So what you have to do is you need to draw an altitude to find the height of that triangle. Now you get a right angle when you drop it down. So guess what? We're looking for this. Okay, I want to know the height. So I have a 60-degree angle, and I have a hypotenuse, and I'm looking for the opposite side. So we're going to do trig. Okay. So I'm actually going to ignore this little piece of my triangle and just look at the right triangle. So again, this is my opposite side, the height, and this is my hypotenuse, which is sine. So I'm going to say sine of 60 is going to equal opposite, so I don't know, over hypotenuse 18. X is up high, I'm going to cross multiply. So remember, your calculator should be in degrees, and you're going to type in sine of 60 times 18. So X is going to equal 15.588. If you want to round that, you can. That's going to be the height of the triangle, okay? So now I know my base of 18, and I know my height. So I'm going to plug it in my formula. So area equals 1/2 my base times height. So area equals 1/2 18 times 15.588. If you want to use the whole decimal, you can. But once you type that in, you're going to find the area of the triangle. It's going to be 140.3. Okay? So now I'm going to subtract my two areas. Area of the sector up here was 54 pi. So I'll say 54 pi. Take away 140.3. So my answer of that shaded area is going to be about 29.3. And let's say we're in inches squared. Units squared, something squared, because it's area. Okay? So again, the hardest part is this step right here, finding the area of the triangle. Drop it down, use trig, and then plug it into your formula. Okay? Thanks for watching. You can practice. Alright, so in this you try problem, I'm actually going to do this one for you because this is a very tricky problem. So when you have a 120 degree of an arc, it's going to be a whole lot trickier to find the area of the triangle. But you can always find the area of the sector first. So you're going to use 120 over 360 times 2 pi and then your radius of 6. So when you type that in the calculator, you're going to get that the area of that section is going to be 12 pi. Okay, so the hard part is to find the area of the triangle. So let me redraw this triangle. I'm going to draw it really big so you can see it. Okay, so I know this piece right here is going to be 120 degrees. Okay, so to find the height, I'm going to drop down an altitude to form a right, so I can have two right triangles. Okay, so if I split up that angle, it's going to make each one of these pieces 60 and 60. Okay, so I actually know that this piece is 30 because I have two separate triangles. Okay, so you can do this a couple of different ways to find the height. Okay, so you know the radius, each of those pieces are 6. So if I want, I can ignore this triangle for right now and just focus on that bottom right one. So I can use 60 for trig, or I can use 30. It's up to us. So if I want to use 30, this is going to be opposite, and this is going to be my hypotenuse. So one way is to do sine of 30 equals x over 6. Okay. The other way that will get us the same answer is if I now stand here, x is adjacent, and now the 6 is still the hypotenuse. So I could actually do cosine of 60 equals the adjacent side over the hypotenuse. Now, both of them are going to give you the same answer. Okay. So you're going to get that the height is going to be 3. So if you cross multiply those, you should get 3. Okay. Now the base. This is the base of the triangle. Okay. They didn't give it to me, so I have to find it. Okay. Good part is if I find this piece right here, I can double it to get the other part of the base. So I'm going to have to use trig again. So instead of looking for the height now, let's call this y. So I'm going to be looking for the base. So again, I can set up two separate equations. I can use this 30 or I can use the 60. So if I use the 30, that the y is my adjacent side. So cosine of 30 equals the adjacent over the hypotenuse. Okay. Again, if I wanted to stand at this angle, y would be opposite, and I'd have the opposite hypotenuse. So I'd say sine of 60 is going to equal opposite over hypotenuse. Again, either way you do that, you're going to find the base of the triangle. Multiply those, you should get that half of that base is going to be 5.20 if we rounded. So this is going to be 5 and 20. So then that means this is as well. So my whole entire base is going to be double of that, so 10, 40. Okay? So now I have my height and I have the whole base. And I can say the area of the triangle is 1/2 the base times the height. So half of 10.4 times 3 is going to give you 15.6. So now that I have the area of the triangle and I have the area of the sector, I can subtract my two answers. So I would say 12 pi subtract 15.6. Okay. So once you do that, you should get 22.099. So that would be 22.1. Okay. So again, if you have a triangle that is 120 degrees, you're going to have to do all of this work for the triangle to find the area. If you've got a right triangle, that's nice because you already know the base and the height. And we saw in the previous one, if it was 30 or 60 degrees, you already know the base. So if you don't know the base of the triangle, you're going to have to do a lot more work. Okay? All right. So why don't you try these three on your own? So this is a pretty simple one because it's a right angle, and these two are very tricky ones. Okay? So try those and then press pause and we'll go over the answer. For this top right one, when you find the area of the sector, you should have gotten 16 pi. When you find the area of the triangle, 1/2 base times height, you get 32. So you're going to subtract the whole sector, subtract the triangle, and you should get 18.3 feet squared. So remember our units I forgot to do on this one. If they give you units, they're going to be squared because of area. Okay. Now these two very hard problems. So first off, finding the area of the sector is not that bad. You should have got 16 over 3 pi. I kept it as a fraction so I wouldn't have a lot of rounding error. Then I had to find the height and the base of my triangle. So I redrew this. Remember, if it's 120 and you make a height for an altitude, it's going to split it in half. So I had 60, and then you'll also have 30 down here. So I used 60 for both of my angles. So to find the height, I said cosine was adjacent over hypotenuse of 60, and I got 1 for the height. To find the base, 7.3. So I did sine of 60 to find the opposite over the hypotenuse. The tricky part, which I forgot to do actually and had to go back, remember when you find the base, you only found half of the base. So if you want the whole entire base, you're going to have to double what you got. So I had 1.73 for part of the base, double it, and got 3.46. So then you can find the area of the triangle, which is 1/2 of the base and the height, and you should have gotten 1.73. So then I say my area of my sector, and I'm going to subtract the area of my triangle to get my final answer of 15.03 meters squared. Okay, so again, the hardest part is finding the base and the height of that triangle. So let's look at this one over here. I'm a little bit different because I'm not looking for this piece up here. I was looking for this whole piece down here. So what I did was I found this area of this major arc down here, and then I'm going to add the area of the triangle to it. Okay, so I had 240. Again, I had 360 subtract 120 to get 240, and so I found the area of the sector was 54 pi. So now I'm going to add the area of the triangle. So down here, had the area of the triangle, I had 120 degrees, so I had to split it in half to 60. I used 60 on all of these problems. You could have used 30 if you wanted to. So I did cosine of 60 equals a over h, and I got 4.5 for the height. For the base, I did sine and did opposite over hypotenuse. I got 7.79. Now remember, you only found half of the base, so you're going to have to add 7.79 twice. So the total base is going to be 15.59. So now I can use my height and my base to find the area of the triangle, which I got 35.0775. Now the more decimals you use, the more exact your answer is going to be. So I know we rounded this one, but if you wanted to use the whole decimal, you could. You'd probably get a more exact answer. So now that I found the area of the triangle, I've got the area of the sector. I'm going to add them two together down here to get a total of 204.72 centimeters squared for the area of that shaded section. Okay, so again, these are the hardest kinds of problems when you have 120 for an arc measure and you want to find the area of a triangle. But you guys can use your knowledge of trig to help you out. But if you have any questions, let me know. But now you can work on your practice more.